Hi, welcome to this video on a few things that every data engineer should know. It is a summary of the book 97 Things Every Data Engineer Should Know, which is a collection of 97 articles or blog posts, which act as a building block for a career in data engineering. It has got articles from experts coming from Twitter, Google, Microsoft, LinkedIn, and so on. This book is very helpful for aspiring data engineers. However, it deals things in breadth and not in depth. So if you are an experienced data engineer, you might be knowing most of the things beforehand. The first section is on the career in data engineering. We will also discuss things like working with cross functions, working as a data engineer, optimizing ETLs, guidelines around those areas. If you are trying to build a career in data engineering, remember, data engineering is a combination of computation, storage, messaging, coding, architecture, along with domain knowledge and the business use cases. You should have good understanding of SQL along with programming language. One is statically typed and one is dynamically typed. You should make use of open source technologies to learn the internals, and even better, try to think about contributing in open source. Experience in your software development lifecycle is going to be very beneficial. However, don't tie yourself to a specific technology or a specific tool. Rather, focus on fundamentals and focus on the problem-solving ability, adaptability in the organization. Once you start to work as a data engineer, you should know some of the fundamental concepts like MapReduce algorithm, distributed programming, in-memory databases, which make fast read and write possible across multiple machines, message passing from one system, one component to the other in an asynchronous way. Tools like Apache Spark and Flink, then Redis or Apache Kafka, Apache Pulsar are going to be very beneficial to make use of depending upon your use cases. Think of automating your resources you make use of. If you are using cloud resources, permissions, storage, etc. Also have a test which is automated. At the same time, test should be reproducible and it should be deterministic. Oh, yeah. Understand the nuance of the event time, which is also the data time, and the arrival time. Event time is when the event occurs, and arrival time is when the data actually arrives to your system. These may not be the same all the time. There could be some lag. So you have to consider concepts like watermarking, like how much delay you expect or anticipate in your data. Based on that, you may also think of batching them based on either the event time or the arrival time. You may have different tables having different partition values, one which is partitioned on the arrival time and one which is partitioned on the event time or the data time. You may create this batching of event time after the watermark, which could be few hours, few minutes, maybe days, based on how much latency you expect in the data to arrive at your system. Think of creating a dashboard where you can measure the quality of the data, you can inspect the shape of the data, you can get it reviewed from other business owners as well. Whenever you are new to a project, understand how the data flows through your pipelines, where does it originate, what are the sources, create documentation if it does not exist. And before you start to design, don't religiously follow the battle of open source versus proprietary. Both softwares have their pros and cons. Inspect them before you make a judgment, but consider both of them. You scale on the grounds of concurrency, make a scalable solution, and understand the language of the business, present your impact, present your case in a language business can understand. Also consider, are you going to capture too many data and use too little of them? What is the value of the data you are capturing? Are you capturing 100 columns only to use 10 of them? Give a thought on the file formats and the partitioning of the files you are going to use. File formats like Parquet, Avro, and ORC, they will give you better compression. But columnar storage, columnar format like Apache Parquet or ORC will give you additional benefits of optimizing selection of a specific columns or filtering out columns which you don't need. Have a tunable compression to adjust between the CPU usage and the storage footprint. Migration can be hard, so think of these optimizations upfront. Try to reduce the number of small files you are producing, batch them together, or use configurations so that you don't create too many small files. Before you start to code, carefully think of the input you are using and the output you are going to produce, the schema involved, the SLA, the constraints, and who is going to maintain the pipeline later. Also think, do you need to backfill and need to be prepared for any such situation upfront? SQL is very important. It has been there since last half century, and it still continues to be widely used. Make your SQL queries structured, which is optimized for the readability first and performance maybe later. Because if it is optimized for readability, you may be gaining the speed of innovation. Try to make use of better readability syntaxes, maybe common table expressions like with as clause. Strive towards developing a better data culture. Be in touch with your data consumers, understand what business problems they are solving. Also try to have empathy around their problems, understand how do they interact with your data sets. Don't hesitate to provide more documentation, more resources, or even conducting a training to help them explore the data or make better use of data. If you could build some centralized tools, that will be even better. Whenever there is external user ask, you think whether you can automate the external user ask. You don't have to work on every user ask, but try to find out a commonality of what are the tools which can help solve large number of problems. Think of user ask as a conversation to start and take it as an opportunity to dig deeper into their requirements. If your consumer wants to collaborate with you or make changes to the system you own, maintain the quality at that in those situations. Or you can set expectations upfront about the quality of your code or the quality of the pipeline you are maintaining. You are the owner, so you have to take a call. Don't try to be a hero who works long hours and gives up work-life balance. Rather, focus on process, tools, and methodology. Heroism is very temporary. Heroes are quickly forgotten whenever there is a new crisis. Moreover, heroism also gives a false impression that things are adequate, resources and methodologies are fine, which may not be the case. So give time to make your pipelines robust, set realistic targets and expectations with your stakeholders, have a development sandbox or testing sandbox. Try to simplify the reusing of your tools or containers, automate as much as possible the tests, the alerts, the reviews. Moving to the data lake and data warehouse, the idea of data lake is to act as a central repository of data integrated from disparate sources. With a data lake in place, you can ensure that you have the visibility at metrics on different granularities like team level, project level, company level. And also if one metric goes up, does other go down? You can have guardrails around all the data you have. Data pipelines evolve from simple to being complex. Simple data pipelines tend to have some SQL queries running directly on the production systems, which could be fine for small data. But as it grows, you may move towards data lake where you ingest data from your source systems and then build metrics using data warehouse on top of those raw data. New breed of data warehouse has made it possible to store and process even larger volumes of data, which includes Redshift and BigQueries. In order to optimize your ETL, you can think of using incremental ingestion in your data lake. So instead of bringing the full database, can you read the bin logs and make use of absurd technologies like Delta Lake or Apache Hudi to work on the incremental data rather than on the entire historical data? Think of how to optimize the query performance by better partitioning or better file formats. You have to think strategically. Think of a way to increase or adjust the storage and computation independently. Do not over optimize for speed, optimize for average user and speed of innovation. Always have a two-way doors. Don't get locked into a specific technology. Don't get a captive of a specific paradigm. Always have the flexibility and the option to choose an alternative in case you don't see things moving in the way you wanted. Data quality is very important. Without data quality, you lose credibility. You can start with quality as simple as column names. Have a well-readable column names with a shared understanding on how you are going to name your columns. Something like ID_driver, needless to say, this is the ID of a driver. TS_origin, it simply means what was the timestamp at the origin. This also helps in data discoverability and metadata management. You should coordinate with the stakeholders to implement the testing which you want, what kind of logic you are going to test, what kind of data shape you are going to test. It could be schema validation, null checks, sensitive data exposure, anomalies, and so on. Also understand if you can implement some business rules in your check. Instead of inspecting one field in isolation, can you make use of multiple fields, inspect them together holistically and see if it makes sense in the business context? For example, lifetime payments should be less than the lifetime purchases. If this is a business use case, is data satisfying the quality based on this logic? Or users in the trial should have $0 in their purchases. These things need to inspect multiple fields and tie them together inside a business logic. You should have validation at every step, right from ingestion till data gets presented. Your quality checks should also evolve with time as the data changes or the business logic changes. Keep an eye on the instrumentation. Many of the poor data quality reasons, most of the reasons of poor data quality is because of poor instrumentation, which leads to garbage in and garbage out. If you have to think on the pillars of data observability, think in terms of freshness. When was the data generated? Distribution of the data, the shape of the data, volume of the data, like has all the data arrived or not, schema of the data, has it changed, is it evolving, and the lineage of the data, what are the upstreams and downstreams. Things which could make data unusable include no quality, no owner, no compatibility in case of schema changes, as well as no support from the data experts. So try to incentivize the owners, have compatibility in the schema of the files. Maybe you can use pre-compiled, maybe you can use compiled libraries like for Avro and Protobuf. Also have a documentation and proper support channel, maybe office hours for new data products so that you can help and support the consumers of the data. If there is any data issue, try to see if it is the issue with the test, in which case just fix the test. Or is it issue with the data? If it is the issue with the data, can you fix it? If yes, something like formatting the data, if you can fix it, just make the logic change in your pipeline. If you cannot, set the expectations to the downstream consumers. Maybe you can work with them to provide the alternatives, or you can also talk to your upstreams to resolve it. ETL pipelines are quite important. You should try to see what are the algorithmic and data flow logic in your pipeline. What are the repeating patterns in your pipeline? Data flow logic can be covered inside reusable component patterns. Think of like a single responsibility principle, or do not repeat yourself from the software engineering. Joins, data wrangling, quality monitoring, sessionization, if these are common, try to bake them as configurations or try to provide reusable functions for them. And for those logic which are algorithmic, which are specific patterns, specific to a business use case, they might be kept separate. If you cannot decouple them, then try to have an ordering in them. Maybe you can have data flow logic in the beginning of the pipeline and all the algorithmic logic towards the end, or the other way around. You should be able to monitor the progress of your pipeline, especially the processing time, how much failure it has, and also focus on the readability. Dense pipelines make it hard to modify and understand by a new team member. When we talk about metadata, it helps you to keep it helps you to perform data discovery, access control, schema, and also if there is any compliance, if there is any compliance met or not met. Metadata system should be able to connect with different systems, and do not consider only the tables as your assets, but consider the dashboards, pipeline code, SQL queries, notebooks, message bus, all of them to be your data asset. So you can think of metadata being a big data in itself. Can you look at the SQL queries and parse their logs to identify some of the metadata automatically? Most of the times you could. Explore that. The operational data lineage helps you track many things and answer a lot of questions, including why a transformation is failing, why a data set is late or why it is incorrect, how to reach out to the correct owner in case of any issues. Message bus give you the ability to perform real-time message exchange or event exchange. Change data capture, where you look at the changes happening in the bin logs or write ahead logs, can give you the advantage of having low footprint on the original data sources and getting all those events in real time to your near real-time storage or your upsert systems like Hoodie or Delta Lake. Whenever you are reading the change data capture into your message bus, also be prepared for performing any historical syncs in case you need that. Usually message bus don't have a very huge lifetime. It could be in few days or few weeks. In case you want to load or reload your historical data, always be prepared for that. Systems like Kafka, Pulsar are very popular as message bus. There are also managed services on cloud, like Google has PubSub, AWS has Kinesis or managed Kafka. You can also make use of message bus to avoid dual writes. So your application need not to write to multiple places. It can write only to one message bus, and from that message bus, you can have multiple consumers who could write to different systems. Also think of a way like, do you really need to read the bin logs? Is it possible for your application to directly send to the message bus and you may not need the database in the first place for all of the events? Also think of backward compatibility whenever you are making changes to the data or events inside the message bus. One guideline can be to create a new topic if the schema is not compatible with the previous schema. Moving on next, think if you can make use of event processing libraries like Akai streams or Kafka streams instead of going to Apache Spark or Apache Flink, which are more heavyweight. His streaming jobs have a requirement to have more involvement in order to keep them healthy and consistent. Sometimes these low footprint event processing libraries can be a good fit for your use cases, especially if you need low latency over not so high volume of data and if you don't have very complex processing. Benchmark your tools. For example, if you increase the number of partitions in the Kafka or increase the replication, does it lead to degraded performance? Or if you start too many consumers at the same time, do you get rebalancing a storm? Benchmark all these situations so you are better prepared. When you talk about NoSQL, first of all, think, do you really need a NoSQL? NoSQL are fantastic in the terms they provide low latency, but if you are trying to perform some aggregate analysis on top of NoSQL, perhaps they are not the best choice. You can make use of pre-generated aggregates. You can do that more frequently, like instead of daily, you can do that twice a day or every hour. Also, whenever you are making use of NoSQL, understand what is going to be your key. The key should have as much high cardinality as possible and prevent hot spotting so that you can make use of distributed ingestion into the NoSQL databases. You can also compare the SQL and NoSQL. In many of the cases, NoSQL look fancy, but SQL is a better fit. So be unbiased in your choice of the SQL versus NoSQL. Think of situations or think of the features like integrity, design changes, programming, and performance before you make a choice. Coming to the privacy and security. If you have all the lineage there with you, you can track the provenance of the data. You can better understand the legal and privacy concerns. You will be able to answer questions like, are the customers aware of how their data is being used? How can you remove the artifacts like data records, for example, of the users whose data we no longer have access to or rights to? Drop and encrypt the sensitive fields. Think, do you really need users' sensitive information to train your model or to perform aggregates? Many times you might not. Just drop those fields. Data engineers have to act as guardians of data whenever they are handling users' information. So just monitor, log, and track access to the machines or containers you use. Learn about the network and computer security concepts and automate the testing of the security. For example, logging in with bad credentials, or are you really encrypting the data? Coming to data product platforms now. When you understand the big picture of the data, like how does it map to your company's goal, you start to receive the buy-ins upfront from the right authority of building the data platform as like a product. Evolve your data platform with the business needs and align on the definitions of SLOs like observability and data quality with your stakeholders. There are different data domains. Some of them are data infrastructure team, which deals with complex system, data scientists and ML engineers who perform the exploratory work, and data engineers for whom exactness of data and maintaining the right pipelines and contracts are much more important. You should always strive to make your end users empowered, else they will create internal IT organizations. And a similar concept which is derived from domain-driven design is data mesh, where you leverage the concept of domain-oriented, self-serve, and autonomy of the data teams. A self-serve platform should empower the users to interact with the tools and infrastructure without having them know about the inner details. Just like you need not to know about the storage details in order to create a bucket in S3. Think of a data mesh, self-serve data platform to be, in that sense, something like a cloud provider is for us. You should give each team end-to-end autonomy so that they are not blocked. They should be able to create pipelines, trigger, stop, delete any pipeline, any data artifact, view the lineage, and reach out to the correct teams, have access to as much data as possible inside the organization, along with proper governance of the data. Now, when working with your cross-functional teams, try to increase the visibility of your data science projects. Understand what was the needs of the stakeholders and create a UI or dashboard to show the progress of the project. Most of the data science projects work is related to exploration, data preparation, and data cleaning, which has little visibility. Keep your stakeholders aware of the progress, and the best way is via regular updates and sharing the data artifacts or UI where you can show them how things are moving and what stage they are. Visibility and reproducibility are two important things. Always try to create your work reproducible. It could be very simple using, if you're using, say, notebook files, Jupyter notebook files, make use of source control like Git, include all the dependencies together, maybe create a Docker file. Eliminate algorithmic randomness from your pipeline so that if you rerun or if anyone reruns it, they will get the same result. Combine visualization in the code along with the explanation. And if you have some idea of how your project is going to be used or how your exploration is going to be used in the actual production project, you can better decide on the data format so that you have less work or bugs to face in the future. Things which can go wrong in an ML project can include assumption on the meaning of a data set attribute, like you assume this field means something, but it is something else. Or having multiple definitions for the same business metric, different teams having different definitions for the same metric. Or the source schema changes without you getting notified, or the models which was used for the training and serving are not identical, or you assume that all the data sets assumed by a given team have the same quality, which might not always be the case. Or finally, one more common reason could be systematic data issue, like you are collecting all the data from the mobile, but maybe some of the events from Android are not getting logged, and you get biased towards your training model gets biased towards data coming from iOS. So these were some of the points in brief. Hopefully you were able to go through it and revise. If you were already a data engineer, hopefully you were able to reinforce what you already learned. Feel free to share if there is any better practice or a good practice which you follow and any new data engineer should know. Thank you so much for giving your attention.